Good afternoon, students. Today we are discussing the important questions from the chapter Acids, Bases and Salts. Okay. Um, Already we have completed the first chapter from the chemistry. So this is the second chapter. So that is the acid, bases and salts. Let us start with the multiple choice question. I hope all are ready to listen the class. Let us first we are discussing the multiple choice questions. Okay. Yes, the first question. As the pH value of neutral solution increases, the pH of value of neutral solution, that is 7. See the option A, basic property decreases and number of OH minus ions increases. Acidic property increases and number of H plus ion decreases. Basic property increases and number of OH minus ions increases. Acidic property decreases and number of H plus ions increases. So here which option is the correct one? As the pH value of neutral solution increases, pH value when 7 to it is increasing 8, 9, 10 like this. Basic property decreases, no. Basic property increases. Acidic property increases, no. Acidic property not increasing. Basic property increases, that is correct one. And acidic property decreases, yes, that is correct. Acidic properties increases. See the next one. And number of OH minus ions also increases. When the basic property increases, number of OH minus ions increases. So C option is the correct one. Check the D. Acidic property decreases and number of H plus ions increases. So here H plus ions not increases. So option C is the correct answer. That is basic property increases and number of OH minus ions increases. Next question. The chemical equation that represents the neutralization reaction among the following is a chemical equation that represents the neutralization reaction. Here, barium chloride, sulfuric acid, so which forms the barium sulfate and hydrochloric acid, manganese oxide and HCl, which forms the manganese chloride, water and chlorine, then sodium hydroxide and sulfuric acid, which forms the sodium sulfate and water, AgNO3 and HCl, which forms the AgCl, silver chloride and HNO3, that is nitric acid. Barium chloride and the neutralization reaction occurs between the strong acid and the strong base. Strong acid and acid and strong base. Strong acid and strong base. Here we can see option C, sodium hydroxide is the strong base and H2SO4 is the strong acid which forms the sodium sulfate and water, which is the salt and water. So that is the correct answer. That represents the neutralization reaction. Which one of the following salts does not contain water of crystallization? Bleaching powder, baking soda, washing soda, gypsum. Here, gypsum, it contains the calcium sulfate CaSO4 2H2O. This is the water of crystallization, right? This is the water of crystallization. Washing soda. So in washing soda also Na2CO3, Na2CO3, 10H2O. It also contains the crystallization of water. Baking soda, bleaching powder. Here bleaching powder, CaO Cl2. So it does not contain any water of crystallization. What is formed when the zinc reacts with sodium hydroxide? When the zinc reacts with the sodium hydroxide, it forms the sodium zincate. It forms the sodium zincate and hydrogen gas. Sodium zincate and hydrogen gas. That is the option B. Sodium zincate and hydrogen gas. Next question. Tomato is a natural source of which acid? Tomato is natural source of which acid? Option A, acetic acid. Option B, citric acid. Option C, tartaric acid. Oxalic acid. Here, acetic acid which is present in the vinegar. Then citric acid which is found in the citric fruits. Tartaric acid that is found in the tamarind. Then oxalic acid. So that is found in the tomato which contain the oxalic acid. Okay, option D. Next question. Brine is option A, aqueous solution of sodium hydroxide. Option B, aqueous solution of sodium carbonate. Option C, aqueous solution of sodium chloride. Option D, aqueous solution of sodium bicarbonate. Here, brine is an aqueous solution of sodium chloride, NaCl. Brine is a aqueous solution of sodium chloride. Option C, aqueous solution of sodium chloride. Next question. Sodium carbonate, Na2CO3, 10H2O is option A, washing soda. Option B, baking soda. Option C, bleaching powder. Option D, tartaric acid. Here, Sodium carbonate is, so that is called as a washing soda. Option A, washing soda. NaHCO3, that is the baking soda, bleaching powder, tartaric acid. So these all are wrong one. Option A is the correct one, washing soda. Next question. Sodium carbonate is a basic salt because it is a salt of, sodium carbonate is a basic salt. Why? Because it is a salt of strong acid and strong base, weak acid and weak base, strong acid and weak base, weak acid and strong base. What is the reason? Because weak acid and the strong base. Weak acid and strong base is the correct answer. Next question. Which of the following statements is correct about an aqueous solution of an acid and a for base? Here, higher the pH, stronger the acid. Higher the pH, weaker the acid. Lower the pH, stronger the base. Lower the pH, weaker the base. Here, lower the pH, when the pH is less than nearer to the 7, weaker the base. Yes, that is correct. Lower the pH, stronger the base. Lower the pH, stronger base. And higher pH, weaker acid. Higher pH, stronger acid. Here, when it is having the high pH, so it is not a strong acid. When higher pH, weaker acid. Yes, second one is the correct. Higher pH, higher the pH, weaker the acid. And lower the pH, weaker the base. And lower the pH, stronger base. So that is the wrong one. So second and fourth one. Option D is the correct answer. Next question. Nettle sting is a natural source of which acid? Methanoic acid, lactic acid, citric acid and tartaric acid. Nettle sting is a natural source of option A methanoic acid, option B lactic acid, option C citric acid, tartaric acid. Here the correct option is, so that is the methanoic acid. Lactic acid present in curd, citric acid present in the citrus fruits and tartaric acid that is present in the tamarind. Next question. A solution turns the red litmus blue. Its pH is likely to be option A 1, option B 4, option C 5, option D 10. A solution turns red litmus to blue. Here 1, 4, 5. So these all are acids. Here the base which turns the red litmus to the blue, that is the option D 10. Next question. 10 ml of a solution of sodium hydroxide is found to be completely neutralized by 8 ml of given solution of HCl. If we take 20 ml of the same solution of the sodium hydroxide, the amount of HCl solution required to neutralize it will be. So here 10 ml solution of sodium hydroxide, 10 ml sodium hydroxide here. So it is neutralized by 8 ml, completely neutralized by 8 ml HCl. So same amount, same NaOH solution, that is the 20 ml of NaOH. So that is taken for the neutralization reaction. How much HCl is required? For 10, 8 ml. For 20, it should be a 16 ml of HCl. So here option D, 16 ml is the correct answer. Next question. Which type of the following type of medicines is used for the treating indigestion? Here, antibiotic, analgesics, antacid, antiseptic. Antiseptic. Here, for the indigestion treatment, antacids are used. Option C, antacids. Okay. Antacids are used for the indigestion. Next question. Name the salt used in the following situations and write their molecular formula. Okay. So you have to write the molecular formula of this. Option A, to remove the permanent hardness of water. To remove the permanent hardness of the water. To make drinking water free from germs. To support the fractured bones in their right position. Here, to remove the permanent hardness of water, what is used here? Which chemical is used here? Here, sodium carbonate, Na2, washing soda, Na2CO3, 10H2O. So this is the washing soda. To make drinking water free from germs. So that is what? That is the bleaching powder. CaOCl2, bleaching powder. And to support the fractured bones in the right position, that is the plaster of Paris, calcium sulfate hemihydrate. Okay, should write the name to remove the permanent of, that is sodium carbonate, sodium carbonate. Then to make the drinking water free from germs, that is bleaching powder, bleaching powder. Then to support the fractured bones in their right position, that is plaster of Paris. Plaster of Paris. Okay, so these are the some salts which are used for the different purpose and their molecular formula. Okay, so very important question. Please note down this. This is the 3-mark question. Next question. The pH values of 4 solutions are given below. Classify them into acidic and basic solutions. Here EFGH solutions, pH value 5, 13, 9, 2. Name the antacid used to neutralize the excess of acid in the stomach. Okay, so that is the second question. Here acids and here bases. Which are acids? E, which is having the less than 7, they are acids E, 5 and H2. So these two are acids because which are having the pH value less than 7. And base, that is F13 is the base and G9 is the base. Okay. So this is the answer for the first question. Next one, name the antacid used to neutralize the excess of acid in the stomach, that is milk of magnesia. Milk of magnesia. Milk of magnesia or magnesium hydroxide, MgOH twice. Please note down the question. Next one. Name the ions responsible for the acidic and basic nature of the substance. Name the ions which are responsible for the acidic and basic nature. Here, the ions which are responsible for the acidic nature, so these are H plus ions, and for basic nature, these are OH minus ions. H plus and OH minus ions. Next question. Draw the diagram to show the arrangement of apparatus used in the electrolysis of water and label the graphite rod. Name the acid which causes the pain and irritation by ant sting and what is the pH of acid rain. So please draw the diagram, show the arrangement of the apparatus, electrolysis of water. Here, next question. Name the acid which causes the pain and irritation by the ant sting, that is the methanoic acid. Methanoic acid. What is the pH value of acid rain? What is the pH value of acid rain? That is just 5.6. When the pH that below 5.6, what is the pH value of acid rain? When it become below 5.6, it is called as a acid rain. The pH value is 5.6. Next question. Explain the manufacturing of bleaching powder. Write any two uses of it. This is the first question. A strong solution of sodium hydroxide is added to the strong solution of hydrochloric acid. What is the nature of the salt solution formed here? Write the balanced chemical equation for this reaction. So this is the second question. Here, explain the manufacturing of bleaching powder. Write any one uses of it here. The bleaching powder is produced by the action of chlorine on dry slaked lime, that is calcium CaOH twice. Bleaching powder is represented as calcium oxychloride through the actual composition is so it is represented like this. Here when the calcium hydroxide treated with the chlorine Cl2 gas, it forms the bleaching powder, calcium oxychloride, CaOCl2 plus water. So this is the very important reaction. Explain the manufacturing also asked, and the chemical reaction is also very important. So what are the uses of bleaching powder? Bleaching powder that is used to bleaching the cotton, linen in the textile industry, for bleaching wood pulp in paper factories, and other bleaching washed clothes in laundry. And one more thing is very important, to make the drinking water free from germs and oxidizing agent in many chemical industries. So these are the important uses of the bleaching powder. Very important, the uses of these salts. So that is one of the very important topic. Next question. A strong solution of sodium hydroxide plus strong solution of hydrochloric acid, that is HCl. What is the nature of the salt formed here? That is sodium chloride is formed, NaCl. Then water, salt plus water is formed here. And write the balanced chemical reaction for this, right? Sodium, that is same. Chlorine also same. Hydrogen 1, 2, that is also same. Oxygen is also same. Here, sodium hydroxide, that is the aqueous. HCl, that is also aqueous. Sodium chloride, that is solid, and water, that is liquid, right? So here, what is the nature of the salt? This is the salt formed here. What is the nature? Acidic, basic, or what? So this is the neutral salt, okay? The nature of the salt, that is neutral. Next question. What is neutralization reaction? Give an example. What is the common name of the compound that has molecular formula calcium CaSO4 half H2O? Please note down the question. Here, when the strong acid reacts with the strong base, when the strong acid reacts with the strong base, it forms the salt and water, salt plus water. So this reaction is called as a neutralization reaction. When the strong acid react with the strong base, they form the salt and water. When the acids react with the base, so they form the salt and water. This is the neutralization reaction. Give example. When sodium hydroxide reacts with the HCl, it forms the NaCl plus H2O. Okay, so this is the answer for the first question. What is the common name of the compound that has molecular formula calcium sulfate? So that is CaSO4 half H2O. What is the common name? It is called as plaster of Paris. Plaster of Paris. Okay. Plaster of Paris. Plaster of Paris. So also called as calcium sulfate hemihydrate. The chemical name is calcium sulfate hemihydrate. Very important. Please, important formula also. Next question. Draw the diagram of arrangement of apparatus to show the reaction of zinc granules with dilute sulfuric acid and testing the hydrogen gas by burning. Label the following parts: zinc granules and soap solution. One of the very important diagram. So repeatedly asked diagram. Yes, this is the diagram. Very important. Please label, practice all the labelings of this diagram. Very important. Next question. The pH values of A, B, C solutions are 5, 6, 7 respectively. Which of these solutions is more acidic in nature? Why? Draw the diagram to show the arrangement of the apparatus used for the testing of conductivity of salt solution and label the graphite rod. Here, the first question is the pH of A, B, C. A, B, C, three solutions are there. So the pH is 5, 6 and 7. Which of these solutions is more acidic in nature? Why? Here, A is more acidic. A is more acidic because it is having the less pH value. When the pH value decreases, acidic nature increases. Acidic nature increases. Okay. So that is the very important. So why it is a more acidic solution? Because which is having the less pH value compared to this B and C. Yes. This diagram is also one of the important diagram. Write the molecular formulae and two uses of each of the following compounds: bleaching powder and plaster of Paris. Here, what is the formula of the bleaching powder here? What is the formula? That is CaOCl2, and plaster of Paris, CaSO4 half H2O. So that is the molecular formula, and two uses of these uses. What are the uses of bleaching powder? Yes, the bleaching powder that is used for the drinking water free from the germs, and it is used to bleaching the cotton, linen in the textile industry, for bleaching wood pulp in the paper factories, and bleaching washed clothes in the laundry. And it is an oxidizing agent in many chemical industries. So that is also very important. And what are the uses of the plaster of Paris? Doctors use the plaster of Paris to support the fractured bone. To support the fractured bone, so it is used. And plaster of Paris used to making the toys material for the decoration and for making the surface smooth. So these are the two uses of the plaster of Paris. Please make a note. Next question. Compounds such as alcohols and glucose also contain hydrogen. Here, the compounds such as alcohols and the glucose, so they also contain the hydrogen but are not categorized as acid. Describe an activity to prove it. Here, the alcohols, for example, C2H5OH ethanol, or glucose C6H12O6. So here they are not categorized into acids. So they contain the hydrogen ions, but they are not acids. Why these are not categorized as acids? Here, to perform this activity, you have to take the solutions of alcohol, glucose in a glucose in a beaker, and cork, and fix two nails on the cork up to the end. Connect the nails to the terminals of the 6-volt battery. When you connect the 6-volt battery through the bulb and a switch, when you switch on the current, you will see the bulb does not glow or current does not pass through the circuit. So in this experiment, we can observe the there is no current passing through the circuit, because it means there is no H plus ions present in the solution. Here, glucose solutions or the alcohol solutions, they do not contain, they do not form the H plus ions. Here, H plus ions are responsible for the current conduction, but H plus they contain the hydrogen ions, but they will not form these H plus ions. Okay, so because of this reason, so these glucose and alcohols, they do not conduct the electricity. Next question. Why does distilled water not conduct electricity whereas rainwater does? Why distilled water does not conduct the electricity? Here, distilled water is pure form of water. This do not contain ions, and no electricity flows in a distilled water. So this is the pure form of the water, and here this do not contain the ions, but and rainwater contain dissolved acids and salts. So the rainwater is the conductor of the electricity. Okay, so that is the very important point. Note down the next question. Why do acids not show acidic behavior in the absence of water? Why do acids not show the acidic behavior in the absence of water? What is the reason behind this? Please note down the question. Why do acids do not show the acidic behavior in the absence of the water? Because in the absence of acids do not show the acidic behavior. So in the absence of the water, because dissociation of the hydrogen ions from acid occur in the presence of water only. The H plus ions, they form in the presence of the water only. Without water, H plus ions will not form. Okay, so for that reason, water is required to show the acidic behavior. That is the reason. Please note down the question. And answer also. Yes, I will stop the class here. We will continue in the next class. Okay. Thank you, dear students.